Now we are going to solve the section of solid example, and the solid that we have selected is a hexagonal prism. So first we try to understand how the hexagonal prism is kept, and then we are going to add the cutting plane as per given condition. So the statement is a hexagonal prism with side base 20 mm and axis 60 mm long is resting on an edge of the base on VP. Its axis being inclined at 60 degree to VP and parallel to HP. So as per given condition, this hexagonal prism is kept on vertical plane and its axis is inclined at 60 degree to vertical plane. So first of all, we draw the true shape, and after that we incline the axis. So we are going to keep this hexagonal prism on vertical plane. So we can see the hexagon in a front view. So that is drawn over here. Each corner of hexagon will represent 2 points. So accordingly, the nomenclature is given. And then we draw the top view. The axis height given is 60. So 60 height is maintained. And we added the nomenclature as per the convention. So here the bottom is 1 to 6 and the top base here is a to E. Then we are going to tilt it at 60 degree because axis this 3C makes an angle 60 with a vertical plane. So I copied this object, I paste it. As this 3C angle is 60, it means this 4D or 5E angle is also 60. So I keep this 4 dash 5 dash as a base, and then I tilted this to the 60 degree. So accordingly, we made the angle. So after that, we completed its front view, and we have maintained the visibility as this point 4 and 5 are away from the observer. So observer is observing this object from this end. So all the edges that are coming from 5 and 4 are dotted. You can see it over here. Okay. And remaining edges are dark. Now, as far as tilting is considered, okay, I'm going to show it for your reference. So I copy it. So this is the base point. I open this ortho mode and I paste it here like this. Okay. Now we have to make this angle as a 60. So now I selected it. I'm going to open the rotate command. So this is the base point. Then I'm going to click on reference. So this is first reference, second reference. Yeah. Now we know that angle is always measured in anti-clockwise direction. And as we selected this 4 dash 5 dash as a base point, so the line passing through 4 dash 5 dash, that is the horizontal line, that XY line, it becomes a reference line. And in anti-clockwise direction, it means in this direction the angle is measured. We required angle as a 60. So we have to put angle from this direction if it is a positive, or you can add the minus 60 angle so that this 4 dash D dash will incline to XY at 60. So I'm going to add angle 60 like this, minus 60, and press enter. Now you can check this angle. So this angle is 60. So here we have to add either positive 300 angle or minus 60 angle so that we can get the required tilting. Okay, so this is about the tilting that we get. Then we show the visibility. Now it's time to represent the cutting plane. So here for cutting plane, the condition is given an auxiliary plane inclined at 30 degree to VP and inclined at 30 degree to top view of axis. Cuts the prism through the base. The section, the plane passes through the point on the axis at a distance 10 mm from the end away from VP. So end away from VP is this one. Okay, this end is away from VP. So from this end, I am going to measure distance 10 mm. Here I am going to mark the point. And from this point, the cutting plane is passing. So there are two angles given for the cutting plane. So one angle it is made with the vertical plane and one angle is made with the top view of the axis. So this 3C or 6F is nothing but the axis line, and with this axis line, this is the top view axis. The angle made is 30, and the angle made with vertical plane is also 30. That means angle made by the cutting plane with this XY line is also 30. It means both conditions are same, because if I pass the cutting plane through it, so that becomes the opposite angles. So both conditions are same, only two different statements are given to us. Now how to add this angle and how to add this cutting plane, that we are going to see now. So I mark a point over here, that is from end away from the vertical plane is this one, and from here the point is at 10 mm distance on the axis. Now I'm going to open the line command, just close this ortho mode and open this dynamic input. Now the angle required with XY is 30. So now I'm going to click on this point and I'm going to move the cursor. Now you can see that as soon as I click on the line, this line becomes the reference line. As soon as I click on the point, this horizontal line passing through this point becomes reference line, and of course, as from this reference line, the angle is measured. Okay, so this is the angle. So this axis angle is 120. Okay, that is from the horizontal line which is passing through the cutting plane. But actual axis angle with XY is 60. So this angle is 60 as we measured it with XY, and we required angle with XY as a 30. So now I'm going to increase this angle. So you just observe the second box of the angle. So this angle I'm going to increase it up to 150. Okay. So this is 150 angle. Okay. So I'm going to add distance over here as 60. I'm going to press tab, and this angle I'm going to add it as 150 and press enter. Now you can measure the angle made by this line with XY. Okay, so this angle is 30. Now I'm going to extend this cutting plane. So below this trim, we have the extend option. You just click on that extend. You just click on this line, and the line will extend like this. Okay, so now you can see that this cutting plane cuts this left hand edge, this middle edge, as well as this bottom edge, and the angle made by this cutting plane with the axis. Okay, so this is the axis. So below this line we have the axis. So I'm going to take this as a reference. So this is first reference, second reference, and this angle is also 30. So here both conditions are satisfied, that this cutting plane makes an angle 30 with vertical plane, as well as it makes an angle 30 with this axis. So now I'm going to make this line and this point in a red color. I'm going to convert its color to red. I'm going to mark the points, cutting points. So here I have one cutting point. Here also I have cutting point. So just zoom it so that we get a proper points. Now select these points, convert its color to red because these are cutting points. Now we are going to add the nomenclature. So I'm going to open DT command. So this point, cutting point on edge 1A is point P. On this 2B, it's point Q. So we just use, so this is point P. This one is point Q. On 3C, we have point R. Here we have two cutting points. So also I'm going to show the point S over here. So here we have two edges, that is CD and FE. So here I am going to represent 2 points, point T and point U. Now select this nomenclature and convert it to red color. So we have total 6 cutting points: P, Q, RS, and TU. Okay. Now we are going to transfer these points in a front view. So now we have to draw the projections. So I can draw projector from this PQ. Now off this dynamic input on this ortho mode. So it is the point on 1A and 2B. So this is 1A and this one is 2B. So I draw projector up to here. Immediately I make this projector faint. I'm going to open the red color and then I'm going to open point command. And here I'm going to mark point on 1A. So this is point P. This is point Q. Now similarly, we are going to represent point R and S on 3C and 6F. So just zoom it. RES, so it is point on 3C and 6F. So you just check where is 3C and 6F. So this is 6F and this one is 3C. Okay, so I draw projector up to this. Immediately I am going to mark point. So this is point on 6F. This is point on 3C. Now similarly, this point T and U, just zoom it. Okay, so this is point TU. While selecting point, make sure that the same point is selected. For that, you can zoom on that particular point. So on CD, we have one point and on EF, we have another point. So check where is EF. So this is EF. So on this line, we have one point and this is CD. Here we have another point. So just draw the projector and immediately mark a point. So we have one point on this EF and one point on this CD. Okay. Now select these projectors and change its color to paint. So now I'm going to add the nomenclature. So open DT command. So this is on 1A, we have point P. On 2B, we have point Q. Then on 3C, we have point R. On 6F, means on this 6F, we have point S. On CD, we have point T. And on EF, we have point U. Now connect these points by using polyline. So P, Q, this R, this point just off this ortho mode. This is point T, this is point U, this one is S, and go back to P. Yeah. So this is the front view of the cutting section. Now we are going to open the hatch command. And I'm going to select the object for hatching. So before that, I'm going to select the hatch pattern as NC31. Select the red color for hatching. And you have two options for hatching. Okay, likewise, currently, select object option is open. You just right click and here you have pick internal point option. Okay, so if you click on pick internal point, you have to select each internal point separately for hatching. So instead of that, as we connected this entire boundary lines by the polyline, so this PQRESTU becomes one object. So I'm going to use select object option. For that, I just right click and I select this select objects option and I click on this object. So you can see that entire object will have the hatching. So in one step, we can do the hatching by using this method. So hatch creation is over. So you just close the hatch creation. Now we have to show the true shape of the cutting section. So now select this cutting plane along with the nomenclature. Also select the point because these points are important. So I selected all the points along with the nomenclature. Make sure that entire things are selected properly. Then open copy command. Select any reference point and move this cutting plane, okay, to some distance, okay, and place it. Okay, I placed it. Now select the entire cutting plane. Open rotate command. Specify base point. So this is the base point. Click on reference. So this is first reference, second reference, and angle of rotation is 0. So it becomes horizontal to XY. Now we can take the projections. So this is the projector of PQ. Open the ortho mode. This is projector of RES. And this one is, just zoom it, this one is projector of PU. Also measure the distance of the cutting plane. So distance between this point P and this point T. So this distance is important for us. So don't forget to show this distance because this is our answer, remember. Many times you forget to show this distance. So take care of it. So I draw the projections. So now one by one, I'm going to mark the points. So this is the projector of P. So this is point P. This is projector of Q. So this is new position of Q. This is projector of R. This is new position of R. This is projector of S. So this one is new position of S. This is projector of T. So this one is new position of T. And similar thing is for U. Now see, this line is not exact horizontal, so I repeatedly I draw this line. So here we have this line U. Okay, so this is new position of U. Okay, now make this, I'm going to mark the points. Point P, Q, R, T, U, and S. Now make these projections faint. Select all lines. Select color code 9. Now open DT command and add the nomenclature to the points. R, T, this one is U, this one is S. Now trim unwanted part of the extension lines. Now open the polyline and connect these points. Okay. Now we are going to hatch it. So open hatch and see 31 red color and select object. Now see the hatching is done. Now we can show any 1 or 2 dimensions of the new cutting section. So I'm going to show this distance. So it is 33 and this distance is 46. Okay, so this is the entire solution of the problem. I just zoom fit it so that you can see it in a one glance. Okay, so here we get the true shape of the cutting section, and we show the distances of that particular true shape. Okay, thank you.